Alright, so I've been sitting on this presentation a while. I thought that I might as well just go through it. So here is my Void Linux overview. I've been on Void for about 3 months and have been really enjoying it, so I thought I may as well evangelize it a little bit to the GNU plus Linux enthusiast community. Key features: this is an independent distro. It is not a fork, obviously meaning that this is not some fork of Arch or Debian or the likes. Rolling release: you can update to the latest system whenever you like just by running XBPS/-SYU, very similar to Arch in that respect. It uses Runit Init by default, meaning that this is a systemd free distribution. I'll get more into Init Systems in a bit. Uses LibreSSL by default, which is the OpenBSD port of OpenSSL. They forked it after Heartbleed in 2014, I think. LibreSSL is gaining more traction and is becoming the default on a lot of different things. Windows 10's OpenSSH client uses LibreSSL by default as well, which is nice. But this was, I believe, the first distribution of GNU plus Linux to include LibreSSL by default. It has its own package manager. This is the XBPS, or the X binary packaging system, also built from scratch specifically for Void. It comes also with an additional, similar to the Arch user repository clients that you could use, like Yowert or things. That's what the XBPS-SRC is for. But they're officially supported packages, like they're maintained on the official by the Void team, but they are not available through the default repos. You need to build them from source, either due to space requirements or the ability to, like, licensing things for distributing binaries of it. But if you're familiar with Arch, you'll be familiar with Pacman and Yowert and things like that. It's very similar. Additional features: it supports a lot of different architectures, 64-bit, 32-bit, and ARM. It also has muscle targets for all of those, excluding 32-bit systems, meaning that if you're hoping to run the muscle version on your primary desktop, you're going to run into issues very likely with multi-lib things. So I wouldn't recommend it as your primary system if you do anything that requires multi-lib, like Wine or something, for example. But it's cool, so if you want to mess around with non-glibc, you can go ahead and use the muscle version. And like I said, it's available for like the ARM releases and the 64-bit releases. Good documentation for an independent distro. This has some of the best documentation that I've seen for any distro, and with supplementary reading through the Arch wiki, you can basically figure out whatever you need to. The more specialized things are kind of in flux right now. They have a wiki page and a docs page for standard implementation. I feel like they were trying to get their own sort of Arch wiki sort of thing set up, but now they've decided to just document the primary features and what makes Void different from other distros in some docs. So that's kind of in flux right now, but they're figuring it out. Many out-of-the-box desktop environments. We've got Enlightenment, Cinnamon, LXDE, LXQT, Mate, and XFCE. They're all pretty good. You do run into a couple issues with the out-of-the-box desktop environments. Like, there's no way that you're just going to set it up, install it, and then it's going to be good. Like, there's some quirks. The LXQT, for me at least, didn't come with GTK fonts, meaning that like icons and things in GTK windows were missing. You still need to do a lot of work yourself to get it up to like a standard desktop environment setup, but having an out-of-the-box desktop environment for just a live USB if you need to do a rescue or installs for people who are maybe not as comfortable in the terminal. You still have to do, oh, I forget what it's called, ncurses. It's an ncurses install on like a blue background, so you're still installing through the terminal, but it makes it more friendly. Good package selection and mirrors. For mirrors, they've got American mirrors, European mirrors, Australian, Singapore, and even Tor mirrors. And most popular packages, including some niche things, are available through the XBPS default repos and non-free repos. It's pretty impressive how many packages they have. They have an independent build server, so it's always up to date with whatever's synced on their GitHub, which is also interesting that that's all public. Like, to update a package, it's all managed through their GitHub, which is really cool. But let's continue on. So this is a fairly big section, and it might get a little bit confusing, but I read up on all of this. There's a good talk from, what's that, IBM-sponsored Linux conference that happened not long ago, where the guy has the talk on the tragedy of systemd. I had this written before that, so hopefully I can expand your knowledge if that's all you know about systemd. So let's move in. So init systems in general, they're started by the kernel and they run normally as the first processor, PID1. They're in charge of managing all other processes, so it's the indirect or direct ancestor of all processes because it spawns a process and that process can spawn more processes, but everything traces back to the init system, which is in charge of managing all processes. So our idea of init systems are kind of traced back to System 5 init, which is, to my understanding, an AT&T release of Unix from a long time ago that hasn't really been updated in a long time. There are still, like in 2008 or whenever, when all of the newer init systems like Upstart and systemd and even Runit and those sorts of things came out, it was all to battle Sysvinit being kind of a pain in the ass for not having all of the functions that you need for a modern init system. So Sysvinit is the ancestor of them all, and it provides basic functionality but no process supervision, meaning if a process crashes, it doesn't know to automatically restart it. It can't tell because it's not supervising them. Usability issues and hard to support daemons running on demand. You could hack things together, and we'll get more into that later with OpenRC, but it was a bit of a usability nightmare. Starts commands serially, which is really not great. Obviously, at the time, that's how things were. You were running on a like a single core processor that does all the commands serially, but on modern systems, you want everything to run in parallel. And it would, not only would the long boot times be caused by serial instructions, but also input-output delays, things like that. It was just kind of archaic, and we needed something new. So what comes along, we have systemd, developed by Red Hat, and it's been adopted by most GNU plus Linux distros at the time out of the box. So things like Fedora, things like, well, obviously Red Hat, things like Fedora, Ubuntu, all of your forks of Ubuntu, so Mint and things like that, are all running systemd, which it has its benefits and its drawbacks. We'll get more into that, obviously. So there's that talk that I mentioned earlier. I'll probably link that in the description if you're interested. But the reasons that people dislike it for not conforming to Unix philosophy is debatable. It's broken into a bunch of components that I'll get into in the next slide, and a big part of that is overstepping the scope of what an init system should be, but that's also debatable for, you know, what is the scope of an init system. That's all kind of up to you. Systemd was designed or described as a Linux plumbing project. So they went in, checked out all of the underlying processes, and thought, okay, what is a much better way to handle these? Because parts of how the system was working at the time really needed to be gutted and updated. So they decided that systemd would be the ultimate way to go ahead and fix all of those in not one swoop, but one overarching collection of packages. And it's a toolkit of many smaller separate pieces to manage the low-level parts of Linux. So systemd is not one giant binary blob. Systemd is broken into a bunch of different processes. So we have journald. Journald provides event logging. This is append-only binary logging, so as long as you have a way to read the binaries afterward, it's fine. But a big thing with systemd is, look at all of this. It provides journald, login, networkd, temp files, time and date, udev, libudev, and systemd boot. Like, compared to what we had back here as the definition of an init system, that seems to be a little bit out of scope, if you can imagine. So some other things that are built in: it has a built-in network manager that provides DHCP for IPv4. It provides VXLAN, which is used for managing like clusters of virtualized computers. Manages temp files, manages your system time. udev is probably the best thing that's come out of systemd. All of these components are usable on their own. Like, you don't need to have all of systemd to enable udev, which is used for managing device connections. Like, if you plug in your USB drive or something, udev will notice that, and libudev comes with the library to interface with that. So being able for applications to know when you've plugged in a drive or some kind of device is a pretty important thing, and currently that's being provided even on Void by udev, but that's just the part of systemd that they forked out, right? They're not using the rest of this. Systemd even has an integrated boot manager. Like, you could forgo grub and just use systemd boot. So all of these things are their own package, right? Systemd comes with all of these. You don't need them all. You could just use systemd as a parallel init system with better service management and supervision, things like that. It's not bad for that, but it's bad, in my opinion, as an engineering project to tackle all of these things under the same banner. So we'll keep going. If you don't want to run systemd for whatever reason, maybe you don't agree with its philosophy, you think it's slow, you think that there's better ways around it, the other init systems that are on the market, we got launched, which is kind of what systemd is attempting to mimic. You can hear more about that in the tragedy of systemd. BusyBox which is used on embedded devices, Runit, and OpenRC. So we'll hop into OpenRC. OpenRC is what Gentoo uses. It's pretty good. What it is like a extra framework on top of Sysvinit to get it to function in kind of a more modern way. It provides parallel service startup, improved network handling, container and virtualization integration, cgroups. It makes Sysvinit a lot better, and it's designed to work with Sysvinit, or the default init system of your current OS. It's fast, it provides all the things that you would need, but it seems, to me at least, to be additional complexity. Like, why would you go through and design this new framework to interface with system or with Sysvinit in order for it to just keep up with other init systems. So seems like a weird solution to me, but Google started using it in their Chromebooks, so it can't be that terrible. And then we have Runit, finally. This is what Void uses, and it was developed as a full and total replacement for Sysvinit. Like systemd, but this is cross-platform, very portable. It has some philosophy stuff in the next page, but it provides everything that you'd want out of just an init system. This doesn't provide networking or container and virtualization integration or some kind of system boot manager, time and date, all those sorts of things. They're managed by other processes. So this is a very minimal init system. What it does is do init and process supervision. So it provides parallelization for a startup, so it's fast, but OpenRC and systemd also do those. And it has minimal overhead. It's by far the smallest out of all the three that I'm talking about mainly here. And its philosophy is to be small, modular, and portable. On the front page of Void's site, they say it's a simple and effective approach to initialization, to initialize a system with reliable service supervision. So to my understanding, Void likes it because of its like an engineering sort of thing, where this does its job and it does it well. Runit also has some stuff about how it likes to keep its code base as small as possible. I think that most of it's got three main parts. It's got SV, which is the supervisor, Runit, which is at PID1, and then it's got a one-third thing, I forget. But it does a startup in 3 pieces, and each of those pieces I think are around like 300 to 600 lines of C. So it's a very minimal implementation, and that kind of clean code leads to a better, more polished product at the end of the day. So now we're out of init systems. Just as one final remark on this stuff, all of them are good in their own way. Systemd for a server makes a lot of sense. It's the industry standard, everybody's using it. But for a home system or a hobbyist or a Linux enthusiast system, for people that just want to use well-engineered software and have a system that runs in a very particular way, I think that Void made a good call by using Runit, and I have had no issues with it. I'm sure that you can do everything that you would hope to do in systemd through Runit, and vice versa, right? But it's just whatever you prefer, and as a feat of engineering, Runit is definitely a more Unix-style approach. So let's get into XBPS. This is the Pacman package manager of Void, and it is very, very good. Like I said at the beginning, this stands for the X binary package system, and it was designed from scratch. This isn't a fork of anything. All of the packages are managed through GitHub, and you can look at the status of the build server. So the GitHub has about, I think that they're nearing 100,000 commits. They are very close, and it's actively updated. All of the changes that go through are managed through that GitHub page, and when they're pushed through, then the build server builds it. I'm not sure how the testing of packages goes, but I'm guessing that once it's built on the continuous build server, it just gets pushed to the repositories and you can upgrade to it. Easy repo installation. It's not that Arch is incredibly difficult, but to enable non-free and stuff like that, it's very easy, and it'll be familiar to Arch users. If you've ever used Pacman, XBPS is basically the same experience. Even the switches for like updating and stuff, when you would do like a pacman-syu, it's the same. You do xbps dash install space dash syu for updating. XBPS has some additional repositories, just like any other distribution that likes to keep everything kind of segregated from one another. The multi-lib and non-free repositories are not available by default. You're just getting your standard current release. And the muscle repos, I touched on this a little bit earlier, but if you're going to be using muscle as your default C library, then you're going to run into some problems with stuff like multi-arch, and some packages aren't available on the muscle repos. Packages are built by a continuous build server and available quickly. And you can do things like dependency searches through xtools. There's good documentation on that, so if you're looking for a certain library or something, like this happens a lot with people who are trying to run games through Lutris, or any kind of wine thing. You'll run into an issue where it says like could not enable OpenGL, missing library, blah blah blah. So what you can do with xtools is search for that library, see what packages provide that library, and then hopefully fix things like that. So it's got good integration, searching is extremely fast, and for me at least, a lot of the time when I would go through the Arch repositories to try and find a package that I was looking for, I would do it mainly through a web browser on the Arch wiki page. I'd search for packages or something, and then would scroll through this web page, then install through the terminal. So that's an extra step, but on XBPS, I'm sure that there's query tools for all kinds of different package managers, but the query system, at least in my opinion, is the best that I've used so far, where it's very easy. You just search by whatever string you're looking for, and it's going to figure things out for you and show you all the packages that you're probably looking for. The Tier 1 mirrors sync to the build server, and these are officially maintained by the Void infrastructure team, so when you're setting your mirrors, you probably want a T1 mirror. But if there is a Tier 2 mirror closer to you, this is like, it's a European project, so some of the official servers are not extremely close. Like it's a dot, I'm not sure where it's located, but it's like a .alpha.de or de.alpha or something, so I'm guessing they're in Denmark or someplace, right? Some Nordic country. Not super close to North America, and you're going to get much better download speeds by going with a T2 mirror, which is a third party, not official, could have stale packages, you know, don't complain to them. If you are familiar with Pacman, I just put these in for kind of quality of life. If you are getting used to using this package manager, you're going to forget what the acronym is all the time. So the way that I started to remember it, before I knew that it stood for the X binary package system, I had XBPS, I was like, Xbox PowerShell is how I had that remembered in my head. But once you get used to it, it's not bad at all. For people that hop around distros, I'm sure that you're like sudo apt-get install on your Arch system, or sudo yaourt install, or yum install or something, right? Like all these package managers, they do basically the same thing, but the syntax is a little different. So XBPS-install-syu, that's going to just update your system to the latest version, answer yes to all of the queries. XBPS-remove-r, this was a big one for me at first too, because you're going to, if you just do XBPS-remove space, then the package that you want to remove, it's only going to remove that package, not the additional libraries and dependencies that it installed. -r will nuke those. Obviously, it's going to check for other programs that require those dependencies. If not, get rid of them. And XBPS-query-rs for whatever package you're looking for will show the remotes and your local installed stuff, so it's pretty convenient. Moving on to the SRC version of XBPS, these packages are, I think that's wrong. I think that they're officially maintained, but they're not available through binaries and must be built from source. Like they all exist on the same place. The XBPS repository and the XBPS-SRC repository are the same place. It's just the build server is only building a select number of packages. Like there are some that are being excluded, like I said at the beginning, either due to space requirements or due to licensing restrictions. So if you're not comfortable at all building from source, this makes it very easy. It's well documented and easy to understand. For more popular stuff, you're not going to have any issues. One thing that you might have some difficulty with is setting up a multi-lib environment. Like you need to basically clone the repository again into a 32-bit target system. You can do cross builds and things, but it's recommended that you'll figure it out when you get there. I needed to install Wine64 through here. Wine32 is available through the standard repos, but if you want 64-bit Wine, you need to install it through XBPS-SRC, which is no problemo at all. Dependencies and things I think are even automatically installed for you, and they all have a little template file you can go through and read, but for most of these things, you'll figure it out. And I also needed to build FFmpeg from source because I wanted NVENC for OBS. For some reason, their FFmpeg doesn't come with NVENC, but I'm not sure why. Maybe it's an NVIDIA licensing thing. Really no pain at all to install it. Just you might run into some problems trying to figure out how to install local .xbps XBPS files. And that's basically it. So I'm still on Void here. I've been using it for a while. The RAM usage is very good. The ability to, keep everything up to date and things are also really good. I'm super happy with it. Kernels updating, I haven't had any kernels break my system, unlike Arch, where you might update your kernel and then you can't boot anymore or whatever, and you have to go to your old kernel and rescue yourself. So I hope that you guys give it a try. I hope that you enjoyed my little presentation, and sorry if it wasn't perfect, but that's what you're gonna get. So thanks.